Hello, my name is Martha Nowak. I'm with Kansas State University here in Olathe, and I have a very short presentation to share with you about infectious diseases, particularly appropriate now with COVID-19. Not everybody's been vaccinated, but the process has been started. So I thought I'd share with you a little bit of background about One Health. I'd also like to share with you a quick little demonstration that you can do with brothers or sisters or a babysitter, sharing with younger kids. And maybe some kids will actually share it with their parents, because that seems to be the largest growing sector of the population that is spreading the disease. So if you'll sit tight with me, I'm going to share the screen so I can start this presentation and we'll get rolling. It's nice to have you. So today we're going to cover the concept of One Health, how disease spreads, and look at examples of infectious diseases like COVID-19, foodborne illnesses, pets and zoonotic disease. This is not meant to be a comprehensive deep dive. This is meant to be a very simple overview that will help, I hope, help people understand how to reduce the spread of infectious diseases. There is a definition for One Health down here in the bottom left of your screen. It talks about it being the study of the interconnections or the interrelationships between people, animals, plants, and their shared environment. And I've put over, so if one part of this One Health unit is sick, it makes it impossible for the rest of the cycle to not be affected. So if people are eating infected animals, they will get sick. If animals are not cared for in a very healthy environment, in a food production system, they will get sick, and maybe the environment will pass on that illness to people that weren't there at the time of the illness. They picked up through the environment, through waterborne, a waterborne transmission. So it's important to understand this whole One Health aspect. We're all part of the same world. And if we're part of the same world, we can share a heck of a lot, water, air, and the things that come with it. 70% of emerging and re-emerging infections are vector-borne or zoonotic. Some of them are listed here: Rift Valley, Ebola, Marburg's. So chikungunya. There are a lot in the world, and some are very species specific, but some can cross species or be transmitted from animals to people. So it's essential that we understand about the whole One Health concept to understand the spread of infectious diseases. So 3 things are needed to spread disease. One is you need a germ. You need an organism. And you need a mode of transmission. And that mode of transmission may be air, it may be by water, it may be by touch, and it could be foodborne. And the organisms can be different species. Sometimes these germs are very specific, only to dogs or only to people, but sometimes they can cross the line and go from an animal to a person. Germs can take many forms. They could be a virus, bacteria, fungus, protozoa, and I bet you can name some examples that you have heard in the news or read in the books or magazines that you have at your disposal, or just in talking with neighbors. E. coli, Giardia, and Salmonella can be found in untreated water that does not come from a faucet or drinking fountain and has not passed your city or state standards. Pathogens such as Campylobacter and Listeria can be found in food, but only if it's not cooked properly. We eat dead organisms, dead germs all the time because we cook them, and that kills them, and then they cannot, they're no longer a threat to our body once we eat them. So fresh fruits and vegetables must be washed well before eating, because many of these we don't cook before we eat it. And along with hands or any other utensils or mixing bowls or counters that are used that will touch that surface. Many infections can be avoided following a few simple rules. Stay home if you're sick until you are well. Cough or sneeze into your sleeve. And wash your hands when you come home and before you eat. Let's do a little demonstration. So I'm going to stop the share of the screen, and I'm going to change the background so you're actually at my house because I'm working remotely. And I'll show you a cute little demonstration with food coloring that I think really drives home the reason why soap is able to defeat COVID-19. So welcome to my house. I have a little demo to show you. So I have a saucer right here. I made it dark so that you could see me put in a high-fat milk. In this case, it's canned cream. We're just going to put a little bit in the bottom of that saucer. I'll show you once again, it's canned cream or evaporated milk. You could also use 2% milk or whole milk. Skim milk does not work. You need fats or lipids in the milk in order to make it work. I'm going to take some food colorings. The gels do not work as well as the liquid food coloring. It needs to be water-based. So I'm going to put a couple drops of green. A couple of drops of blue. And a couple of drops of yellow. Once again, you can do this at home. You can buy stuff at, buy the materials at Dollar General and have fun. Next thing I have for you is a Q-tip. And the Q-tip has been dipped in dishwashing detergent. There is no particular dishwashing detergent that's best. It's just a liquid detergent. Now, all liquid detergents have lipids dissolved in them, fats. This is how they work. They actually hook on to the grease that's in your pan, and then they break it up. They grab onto it. So we're going to show you how this, you're going to lightly touch the surface of this cream, not where there are the colors, and these colors will start swirling. There we go. I did have to touch the color, didn't I? Notice how it spreads out. This water-based food coloring does not like and gets repelled by the lipids in this dishwashing detergent. If we put it over here in the green, same thing happens. They just start spreading. I might put it a little closer so that you guys can see better. Here's the blue. And it's really fun when you do it yourself in your own kitchen. But these are not being stirred by me. It's a chemical reaction with the lipids in the dishwashing liquid and the fats that are on the surface of the milk that I put into the container, into the the dish. So these are not being mixed by me, but by a chemical reaction. These lipids in the soap are grabbing onto the lipids in the milk. And when they do that, it causes the colors, it causes a current in the milk and causes the colors to mix. And you can keep going. It will react depending on how much dishwashing soap you allow to absorb onto the Q-tip. You can keep going for quite a while with this fun experiment. So you can see the lipids in detergent actually react with the lipids or the fats in the milk. Okay. Let's go back to the presentation. So I'll share the screen again. And we were down about, nope, further along. Only problem with doing these presentations is it goes back to the beginning instead of pausing. So here we go. This was our little demonstration. And I'm going to show you the next thing has to do with a little worksheet I came up with. I made a model of the COVID-19 virus and I put it on paper. Get my other play toys out of the way and show you this. Oh, I need to have it not on virtual for you to be able to see, but this is the model. And I have taken this and I'm going to show you how, with a model, how the COVID virus is actually torn apart by the soap particles. So here we go. Here is, put it on the background that has no background because you'll be able to see that better. So here's our model. I'm having a hard time seeing what you're seeing. Let's see if I can do this better. Here we go. Okay, so here's my model. And you see the lipids are these red triangles on the end of this model. It has like little spikes. And here is where a lipid is going to come in and grab the lipid on the coronavirus. And I do that by cutting out this part right here, and I folded it. So you can see where this was straight, and then I folded it, showing the red part grabbing the other part. And now, let's see if I can do this. It's backwards. Here we go. So when it grabs it, it pulls it away. And you know what happens is then all that what in the inside, all those little black wormy things are the things that will reproduce the virus in your body. And the soap actually tears the virus apart and lets those black things swim out into the wastewater and with your soap, and it goes out into the water and it doesn't enter your body. And if you'd like, I can send you the worksheet, and maybe it'll be fun to provide for your students, or you can tell somebody else and demonstrate. But you can see how this piece goes into there. This yellow triangle covers the red triangle, hooks onto it because it's a lipid. It wants to grab onto, it's like a magnet, hold onto it. And then when it pulls it away, it makes a hole in the skin of this virus. And then this black stuff can go out into the environment and no longer be protected in that nice little neat package. All right, let's go to the next one. All right, we're going to spend just a little bit of time on foodborne illness. So 1 in 6 people will be affected by foodborne illness in the US every year. This can be reduced by 4 simple rules. You can cook your meat to an internal temperature of 165 degrees, use a meat thermometer, and so many of them are digital, and you don't have to worry about breaking the glass, and it's got a little probe on the end of it, and it just folds out and goes right into the meat, the center of the meat, and it can tell you what the temperature is. So you're actually cooking those pathogens so they're no longer going to harm you. You can chill leftovers quickly and mark it with the date it was made so you know when to throw it out. Don't wait for mold to grow on it. And the other thing is to clean all surfaces, including hands and utensils and mixing bowls and knives and spoons and beaters, things used to whip the stuff with. So clean everything and do not cross-contaminate. You see there's chicken here in the middle and we've got vegetables out here. If these vegetables, let's say you cooked up your meat and you're letting that cook for a little while and now you want to cut up your vegetables for your salad, don't use the same cutting board. Or if you do, please wash it with hot soapy water and dry it and then put on your vegetables. Because if you do not have a kill stage to your meal preparation, you have live germs going into your body. So salads are a particular concern if they're not washed really well and not cross-contaminated. Okay, I'm going to move real quickly to the next thing, which is about your pets. Your pets may share more than hugs and kisses. After all, we all share the same environment, and they don't leave their shoes at the door like some of us do. They love to give us hugs and kisses, but it's not always safe. The other thing is to pick up pet waste so it doesn't get into the water supply. So wash your hands afterwards so you don't transfer germs to other surfaces. And that's so that it doesn't get into our creeks or our lakes. The cities do clean our water, but it would be helpful if they didn't have to clean up extra stuff like pet waste. Take your pet to the vet for regular checkups and immunizations, just like you go to the doctor for yours. Because if they have their immunizations, then that makes you safer as a pet owner. Some things can be noticed by veterinarians that we don't notice as pet owners. And sometimes we notice something as pet owners that our vets need to be made aware of, why we're there. And particularly rabies is very deadly for people. So make sure they get their rabies vaccinations. And wash your hands after handling your pet. These are some of the resources I used. And if you have questions, be sure and contact me at K-State Olathe, and there's my email. Thank you for letting me share this information about One Health and about infectious diseases.